dear students, how are you all? Have you gone through the topics that I taught you in the previous class? Yes, all my dear students are good ones. Do you miss your school? Do you remember last year during this month we went to a trip to Wonderland? You were too much enthusiastic to go there. Do you remember how did we go? We went in our school bus, right? And you were sitting in the bus. You came early in the morning and you started sitting in the bus. And suddenly, when the driver started the bus, did you feel a backward jerk? Yes, you will definitely feel a backward jerk. Do you know why? Why did you feel a backward jerk when the driver suddenly started the bus? Why didn't your body travel along with the bus when the driver started the bus suddenly? Have you ever wondered about this? Do you have any such similar situation in your daily life? How do you come to your school? In bus, in auto, or in bike, or by walking? When you travel in bus, have you observed that your body will experience a sudden backward jerk when the driver suddenly starts the bus? Have you ever experienced this? Yes, we all have experienced such a situation. Do you know why? Why do our body experience a sudden backward jerk when the vehicle moves forward? It is experienced when the vehicle starts initially. Do you know why? Can you associate with the topic that I taught you in the previous class? What did I taught you in the previous class? We learned about inertia, right? What is inertia? Inertia is the inability of a body to change a state of rest or of uniform motion along a straight line until and unless an external unbalanced force acts on it. Or else we can say in another way, inertia is a property of a body by which a body continues to be in a state of rest or of uniform motion along a straight line until and unless an external unbalanced force acts on it. Do you remember the law of inertia of motion? Yes. Now, leave inertia of motion and consider only inertia. And can you explain why our body felt a backward jerk when the bus moved suddenly? When the bus moved forward, why did our body went backward? Can you explain it with inertia? I have given you many clues. Now you can explain it by yourself. Yes, this phenomenon is due to inertia of rest. Inertia of rest is a property of body by which the body continues to be in a state of rest until and unless an external unbalanced force acts on it. Or else we can say that inertia of rest is the inability of a body to change its state of rest until and unless an external unbalanced force acts on it. Initially, you and the bus was at rest. Your lower part of the body, that is your feet, which had relatively lesser mass than the upper part of the body, was in contact with the bus. Do you get that? Initially, you and the bus was in rest. Your lower part of the body, that is your feet, was in contact with the bus, whereas the heavier part of your body, that is the upper part of your body, was not in contact with the bus. Only our legs are in contact with the bus. And suddenly, when the bus started moving forward, what happened? The lower part with less mass, which was in contact with the bus, moved along with the bus, while the upper part, because of its inertia of rest, it continued to be in its state of rest. It couldn't move forward along with the bus. Your upper part, with a heavier mass than the lower part, had a tendency to remain in the position where it was. It continued to be in the position where it was. It could not move along with the bus. This is due to inertia of rest of your body. Each and every object has inertia of rest. We can explain this and discuss this using a video.
ഞാനോ വേറെ ആരെങ്കിലും വണ്ടി ഓടിച്ചാൽ മതിയോ? സീറ്റ് ബെൽറ്റ് ഇടും.
Here, the passengers experience a backward jerk due to inertia of rest. Inertia of rest is a tendency of a body to continue to be in its state of rest. So you learned about inertia of rest. What is the speciality about the month of May? It is a vacation time, right? And it is a mango season also. Do you all like mangoes? Yes. Imagine a situation that you had a mango tree near your house. It was full of ripe mangoes. One day, you and your siblings went to collect those mangoes. What did you do? You tried to shake the mango's branch, and as a result, what happened? The mangoes fell down. Do you know why the mangoes fell down when you shake the branches? Can you explain it using inertia? You can definitely explain it. Try to do that. Okay, now let's see how this happens. Initially, let us assume that this is the mango's branch and this is a mango stem and this is our big mango. So this is the initial position of the mango's branch, stem and the mango. And let us see about this mango's stem. This mango stem is in contact with the branch, right? It is in contact with the branch and it is having less mass. Okay, what about the mango? The mango is in contact with the stem and it is having more mass. Do you get that? Now, on shaking the branch, what will happen? Let us see the situation. Your branch moved towards much more forward. Okay. This is your branch. And this much is the distance between the branch and the stem. So the stem will remain attached with the branch. Okay. While your mango with the more mass continued to remain where it was. The mango exhibited its property of inertia of motion. Inertia of rest. The mango continued to stay where it was. The mango didn't move along with the stem. The mango couldn't move along with the branch or the stem. It is due to inertia of mass of the mango. And now let me ask you, is there any relation between mass and inertia? Here mango is having more mass. So it will experience more inertia. And hence it could not move along with the stem and it stayed where it was and the connection between the stem and the mango got broken and the mango fell down. So the mango fell down due to inertia of rest of the mango. And you have seen that mass is a measure of inertia. Object with more mass experience more inertia. You can find similar situation in your daily life also. Try finding that. Let us now discuss law of inertia of rest. According to this law, every object continues to be in its state of rest until and unless an external unbalanced force acts on it. This forms a part of Newton's first law of motion. Okay, now let's summarize. We learned about inertia of rest. We learned law of inertia of rest. We also observed that mass is a measure of inertia. Now there is a home assignment for you. You have to explain law of inertia of rest. You have to explain why is it dangerous for loaded vehicles to negotiate curves in the road without reducing speed. Thank you so much for listening.